The James Webb Space Telescope is fundamentally challenging established scientific understanding, creating a scenario where every textbook concerning the universe's origins may soon require revision. For decades, Pluto has persisted as one of our solar system's most enigmatic members. Since its initial discovery in 1930, astronomers and space enthusiasts have collectively pondered the mysteries of its icy surface, the secrets concealed below its frozen crust, and the insights its peculiar orbit might provide about our cosmic neighborhood's outer limits. A tantalizing preview was offered in 2015 during the flyby of NASA's New Horizons spacecraft, which delivered our first close-up images. These breathtaking pictures revealed mountains of ice, vast plains, and hints of a thin atmosphere. However, as incredible as this data was, the New Horizons mission was merely a brief flyby. It arrived, captured images, and continued on its journey, leaving scientists wanting more for nearly a decade. Now, the James Webb Space Telescope has provided something extraordinary. By utilizing its unparalleled infrared capabilities, Webb has captured an image of Pluto that is profoundly different from any previous observation. It is not simply a clearer picture, but a deeper one, with every pixel seeming alive with intricate detail that reveals textures and patterns invisible to all prior telescopes. This new data is far more than another snapshot. It is a window into an alien world located over 3 billion miles from Earth. The significance of this advancement can be understood by comparing the two missions. If New Horizons provided a postcard from Pluto, the James Webb Telescope has delivered a high-definition, full-length documentary. Unlike a passing spacecraft, Webb can observe, study, and peel back the layers of the cosmos. By directing its golden mirror segments toward the dwarf planet, it has produced an image that feels less like a telescopic view and more like standing in orbit around Pluto itself. This single image represents a monumental shift in our perception. For years, Pluto has symbolized the very limits of human curiosity, a distant cold and isolated tiny at our solar system's edge. Webb's powerful instrumentation has now transformed that into a complex world. We can observe surface variations with unprecedented clarity, including regions of nitrogen ice, hints of shadowed craters, and subtle color changes that suggest complex chemistry. Each new detail contributes to the emerging narrative of a world far stranger than we ever imagined. Crucially, Webb's infrared eyes do more than take pretty pictures. They detect temperature differences, chemical fingerprints, and interactions with Pluto's thin, tenuous atmosphere. This transforms what was once thought to be a frozen, silent world into a landscape alive with invisible activity, like watching a frozen painting shift into a living, breathing vista. The truth is that we have only just begun to scratch the surface of what Webb can reveal about Pluto. This remarkable image is as more data is analyzed. Astronomers believe we could uncover secrets about Pluto's geology, its seasonal changes, and even the potential for a hidden ocean beneath its ice. The next time you gaze at the night sky and contemplate the edge of our solar system, remember that thanks to Webb, that edge has become a whole lot closer. However, before delving into what Webb has actually found, it is essential to rewind the clock. To fully appreciate why this new image is such a monumental achievement, we must revisit Pluto's complicated past story filled with discovery, controversy, and endless fascination. When Clyde Tomb first spotted Pluto in 1930 through a telescope at the Lowell Observatory in Arizona, the world was captivated by the revelation of a new planet orbiting as a frozen sentinel in the dark at the very edge of our solar system. For decades, Pluto held a special place in astronomy as the little planet that could. Textbooks were rewritten. School children memorized its name as the ninth planet. It became a symbol of discovery itself. Yet Pluto's story was never simple. Astronomers soon realized it was much smaller than initially thought. At just about 1,500 m across, Pluto is barely two-thirds the size of Earth's moon. For a long time, scientists were puzzled over how something so tiny could be considered a planet on the same level as giants like Jupiter or Saturn. This debate reached a boiling point in 2006 when the International Astronomical Union (IAA) made a controversial decision to redefine what constitutes a planet, establishing three strict rules. A planet must orbit the Sun, be spherical in shape, and the critical deal breaker for Pluto, it must clear its orbit of other debris. While Pluto passed the first two tests, it failed the third because its orbit overlaps with the icy bodies in the Kuiper Belt, a vast region of frozen objects beyond Neptune. Consequently, Pluto was demoted to a dwarf planet. The world reacted with shock. Headlines blared, science teachers scrambled, and millions felt a strange sadness, as if a beloved friend had been unfairly stripped of a titleless sentiment that persists for some who still refuse to accept the demotion. Herein lies the twist. Losing its planetary status did not make Pluto any less fascinating. If anything, it made scientists more determined to study it. This determination directly led to NASA's New Horizons mission, which launched in 2006, the very year of Pluto's reclassification. After a nearly decade-long journey, the spacecraft finally reached Pluto in 2015, and the world was once again left in awe. Those first close-up images revealed towering ice mountains, heart-shaped plains, and a surprisingly active surface for such a small, cold world, proving that Pluto was not just a dead rock drifting in the void, but a dynamic and complex body alive with geological activity. The controversy around its status helped fuel public fascination, transforming this icy world into a symbol of curiosity, resilience, and our ever-evolving understanding of the universe. Science is not a static discipline. It evolves, questions, and redefines itself. Pluto's reclassification served as a powerful reminder that even our most certain knowledge can shift under the weight of new discoveries. This is what makes the James Webb Space Telescope's new image so profoundly powerful. It is not merely about achieving a clearer view of Pluto. It is about continuing a story that began nearly a century ago. From its discovery to its demotion, Pluto has remained at the center of astronomical debates, emotional attachments, and groundbreaking missions. Now, Webb adds a thrilling new chapter, one that may reveal Pluto's secrets in ways we never imagined. But what exactly did Webb's powerful eyes capture when its golden mirror turned to war of the distant dwarf planet? The answer is nothing short of breathtaking. When the James Webb Space Telescope trained its 21-foot golden mirror on Pluto, the result was astonishing. For the first time saw the dwarf planet with a clarity that rivaled and in some ways even surpassed the New Horizons flyby. Yet this achievement was about far more than just sharper pictures. Webb's advanced infrared instruments revealed aspects of Pluto that no visible light telescope could ever capture. At first glance, the image appeared almost surreal. Pluto glowed against the blackness of space with crisp edges, rich contrasts, and a level of surface detail astronomers had craved for years. The blurry, grainy shapes of earlier telescope photos were replaced by fine distinctions between icy plains, rugged mountains, and mysterious shadowy regions near the poles. Even the famous heart-shaped Tomba Rayo, which captured the world's imagination in 2015, came into view with new layers of texture and subtlety. The true magic, however, came from Webb's unique ability to see in the infrared spectrum. Unlike New Horizons, which snapped photos as it zipped past, Webb can linger and study how Pluto reflects and absorbs heat, enabling scientists to map its surface composition in exquisite detail. In this latest image, differences in nitrogen ice, methane ice, and complex organic molecules leap out with stunning clarity. Regions that once seemed uniform now look alive with variation reminiscent of patches of Earth seen from orbitite deserts, seas, and continents constructed from frozen alien chemistry. Even more fascinating was what Webb detected in Pluto's thin, fragile atmosphere. While New Horizons had previously identified hints of haze, Webb went deeper. Using its spectrographs, It identified faint signatures of hydrocarbons and possibly even subtle seasonal changes. It is a staggering notion that a world 3 billion miles from the sun, with a surface frozen solid, is still breathing out gases and interacting with its environment, as though whispering secrets through the vacuum of space secrets that Webb is now sensitive enough to hear. Perhaps the most jaw-dropping aspect of the new data is how dynamic Pluto appears. Instead of a static frozen wasteland, Webb's view suggests ongoing surface activity. Subtle variations in brightness and texture could hint at shifting ice, migrating frost patterns, and even geological processes bubbling beneath the surface. Some scientists speculate that a subsurface ocean may still be trapped under miles of ice, slowly reshaping Pluto over time. For space enthusiasts, these revelations are thrilling. For scientists, they raise profound new questions. How active is Pluto really? Could hidden oceans or chemical reactions make it more than just a ball of ice? And what does this tell us about other icy worlds like Triton or Europa? This crystal-clear look is more than an upgrade in image quality. It is a reminder that even tiny, distant worlds are brimming with complexity and wonder. Pluto is no longer just a distant, but a world with character, history, and mysteries that could reshape planetary science. Webb's discoveries, however, extend beyond beautiful pictures. The telescope's data has revealed surprising details that challenge long-held assumptions about Pluto's environment, with some findings rewriting what we thought we knew about the icy dwarf planet and hinting at possibilities that could change our view of the entire solar system. If the scrambled 12th frame was the lock, then the question haunting scientists was simple. Where was the key? Some argued the key never existed, proposing the anomaly was merely noisa, natural consequence of the Cassini spacecraft systems burning up in Saturn's atmosphere. Others were not convinced, noting the data did not behave like random static, but carried the fingerprint of intent with patterns that repeated just enough to suggest design, yet collapsed the moment anyone tried to force them open. When a quantum AI pushed deeper into the data, a strange feedback occurred. Systems that had effortlessly handled terabytes of raw space data began to loop endlessly. Processors overheated and memory caches filled with recursive code. It was as if the missing image was not just scrambled, but was actively resisting decryption, raising the terrifying possibility that it was not meant for us or worse, was meant only for those possessing the right cipher. Something humanity had not yet discovered. This was followed by an eerie silence. Every attempt to probe the corrupted frame resulted in outages, a phenomenon teams called the hush, during which terminals would dim, fans would stop spinning, and laboratories would fall into an eerie stillness, broken only when power returned, as if nothing had happened. Engineers insisted it wasn't possible, yet it occurred again and again. The 12th frame had transcended its status as mere data, becoming a forbidden relic that was locked away in air-gapped servers and studied only in brief intervals. The longer it was analyzed, the stronger the hush effect seemed to grow. Some whispered that Cassini's last gift was not an image at all, but a messenger message sealed in silence. A handful of researchers went further, suggesting the missing frame was not scrambled beyond repair, but was intentionally encrypted. They proposed that what Cassini captured in its final instant was so significant, so dangerous that the universe itself, or something within it,